Okay, third time is the charm. Hello, Black people in cryptocurrency, as well as my Facebook friends and anyone else who's tuned in for the interview with Conduit's Ryan Robinson. Ryan started Conduit. He's an MIT grad, and I'm going to bring him in to talk about his venture, which is a quantum computing venture. It's also a blockchain venture. But I want to do a little sharing to the groups to make sure that the live stream is viewable beyond my wall to not just people who tuned into my wall, but actually members of the Black People in Cryptocurrency group. Little backstory on Black people in cryptocurrency and why we don't do as many interviews as we used to. We're moving into the direction of helping HBCUs to join different blockchain groups to further their education. Let me start. Probably best bet is probably start a watch party. We're going to move in the direction of helping HBCUs further their education in general blockchain, as well as helping a little feedback. Hold on. Okay, it's better. We're going to also focus heavily on the startups that are in the sector and founded by Black people so that they can get better access to media coverage, as well as better access to funding opportunities, better access to network with people who aren't of African descent, better access to network with people who are of African descent. So we are hoping that Black people in cryptocurrency really expands to be, as I put it, a finger on this blockchain body, so that we can see and realize some of the startup founders that are well deserving and have something to contribute to the global space. So we had a little technical difficulties earlier today, which is why we're starting late. So what I'm going to do, and Bob, I see you on the call. Can you start a watch party for the Black people in cryptocurrency group? Because when I do it, I get feedback on the call, so I had to quit though. I think I did start a watch party. Okay, it started. I had to get out of it real quickly, so never mind. I'm gonna do a Facebook Messenger call with Ryan. We had some technical difficulties earlier, and we couldn't get on the call together. So give me 1 second. And I'm going to set up my messenger, which means I won't be able to see what's going on except for on my phone. And let's just see if I can give him a call real quick. One second. Hold on, let me take some words. Let's make sure he has Messenger installed on his phone. I can seem to find the icon. Oh, look, found it. Never mind. 1 second. Make sure my volume is up. I'm going to reverse the screen.
Hey, can you see me?
Yeah, I can see you.
There we go.
Let's see if I can.
What is it?
I'm just gonna make the screen a little bit bigger.
Make it bigger?
Yeah, no, I'm making it a little bit bigger so I can see you. All right.
Oh, okay.
All right. So how you doing?
Good. How's it going, everybody?
Doing fine. Yeah, after all our technical difficulties, I think we got something going.
Yeah. No, I understand. So I was trying to find Wi-Fi for the longest. I was like up and about, so I definitely understand.
Oh man. So let me start right off the bat. I'm gonna start kind of non-traditionally. Usually I tell people hit me up with your bio right away, but as soon as I started promoting you, I got an inbox message that said, how does he know he's the world's first quantum engineer? So how do your LinkedIn page has a tagline that says world's first quantum engineer. How do you know you are?
Right, great question. So actually my professor at MIT, Seth Lloyd, he's actually the world's first quantum mechanic. And so pretty much what I did before I even graduated MIT is I asked him, are there other quantum engineers like me, especially in the context of what we're studying, in terms of the hardware of a quantum computer. He said no. And so then he signed my form. I would have graduated actually as the world's first quantum engineer unless he officially proved it as the world's first, with him being the world's first quantum mechanic.
Wow. Okay, so you're answered that particular question. So let's back up a bit. Give me an idea of your roadmap and how you eventually end up with the major that you had at MIT, and then how that has segued into Conduit.
Absolutely. So it started off actually when I was in high school. I was reading a book called Quantum Man, and it's the biography of Richard Feynman. Richard Feynman, as probably knows, was amazing. Also an MIT alum. And so his work is a lot with quantum electrodynamics, quantum chromodynamics. And the last thing he was really working on was quantum computing. He actually made the first paper, real paper, about quantum computing in 1981 at MIT. And so me reading by him, just inspired by his legacy and physics and everything, inspired me to want to pick it up as well. So then I went to MIT, and I actually started off studying something called mechatronics, which is a combination of all the engineering, so mechanical, electrical, computers, systems, materials, all of them combined into one. And once I got to MIT, I was taking like twice the course load, and I came in with credit already for my AP classes. So by the time I was a sophomore, I finished mechatronics, I finished, a lot of the basic requirements, and then I transitioned to my next thing, which was quantum computing, where Seth Lloyd, again I mentioned before, was my advisor. Seth Lloyd is important because he wrote the first paper how to actually physically build a quantum computer. So you have Richard Feynman in 1980, who wrote a paper of what a quantum computer would look like. He called it the universal simulator. Then fast forward about 10 years later, maybe 11 years later, there's Seth Lloyd, who writes how to actually physically build one, a very limited one. And then fast forward, then he's my advisor, and also my teacher too. I took all his classes. And that's what got me into officially becoming, like I said before, the world's first quantum engineer. And what led to that transition into Conduit, in terms of what we're doing, and it pretty much just, it was about, I was really inspired by personal computing. I'm really inspired by commercial electronics, seeing what, the effect of smartphones, the effect of video games. And so for me, I've always wanted to make something that technology that everybody can use. And with quantum computing as nascent, as new as it is, and also as powerful as it is, I saw an opportunity to focus on quantum computing, not just how Google and IBM are doing with it, focusing on, say, military research, security application, but more on a commercial application, more in terms of applications that everybody can use. And so what Conduit's ultimate aim is, what we do is we bring all these supercomputers together. And actually goes into, I know you mentioned the Google leak, is that all quantum computing has to be verified via classical simulation. And so we pretty much made this big classical simulator, and we're going to be using that in the future to be designing and testing quantum computing code in the spirit of making applications for everyday people.
Okay, so yeah, I did. It's a good segue because I did allude to in our private conversations about the Google leak, and the news that came out was that it posed the end to Bitcoin if there's ever quantum computing is ever a possibility. So I wanted to know your take on this kind of news rush that appeared because it was leaked that Google was maneuvering into the quantum space, and because it basically can break the cryptography of people's keys. What was your take on this kind of news burst that happened about 2 weeks ago that if you have quantum computing, it pretty much makes cryptocurrency null and void?
So I've actually spoken about that same topic at MIT and at Carnegie Hall. So it's a great question. Honestly, when I read it, I wasn't surprised. Number one. People in the community have been, already know that the kind of benchmark as we define it now is 50 qubits. So in terms of the sheer number of qubits, they hadn't really made really a big improvement around what we already knew was possible, what existed. In terms of their claim for quantum supremacy, that, I mean, it was kind of like if you kind of like, wink your eye a little bit, if you kind of look real hard, it was one of those things where it did, in a way, prove quantum supremacy, but not perfectly, not up to the proof of, say, academia. So actually, if you look at, there's actually a professor in Israel who says how the paper itself didn't actually show that the quantum computer they used truly did sampling, truly performed sampling. It was kind of pretty much an assumption that was made in the paper. It did not account for what's called noise. It's pretty much the error that happens when you're using it for a computer. So it's like it fit if you kind of took away some of the actual criteria for meeting quantum supremacy. In terms of the cryptographic part of it, is that you were still definitely far away, practically speaking, from cracking cryptocurrency. And you would need thousands of qubits to really get there. And keep in mind, just like everything, if you have 100 qubits, getting that 101 qubit and 102 qubit gets harder each one. So when we've gotten to 73, according to Google, D-Wave says that they do it as well, so they have more. That's very questionable. They're not. D-Wave is also considered one of those, like, okay, if you close both your eyes and turn around real twice and sure, where D-Wave isn't truly considered a quantum computer either. And so my point being is that we're definitely far away from actually cracking true cryptocurrency, which is fortunate. So we have time for the policies both on a national and international level to adjust. And there's already work being done into quantum cryptography that allows you to detect if someone was had touched your code.
So how far away do you think we are from that? 5 years, 10 years? And do you think that, cryptocurrency would be the first or only target? Oh, audio. Okay, go ahead.
So that's a great question. So in terms of the time span, in general, the consensus is about 20-ish years. The idea is that we need about two major, milestones to really accomplish. In general, that being, implementation of a 1,000 qubit computer. And of course, two is actually true application, right? Like, right. There was just a paper at the beginning of this year where it disproved the major use case that we thought quantum computing would have. We thought it would have an effect on something called the recommendation problem, meaning that when you go on Netflix or Amazon, what movie should you watch next? What product should you buy next? We thought that quantum computers would make a huge difference on that. It turns out that there's an algorithm that can be run on a classical computer that still makes classical computers a lot faster. And so with that, we're expecting to have the kind of consensus about 20 years. Now keep in mind, is with more injection of capital, more research, more people in the field, they could easily shorten that. So I personally could see it being done in about the next, honestly, 10, 15 years personally. But I don't think cryptocurrency will be the first target. The reality is going to be what, honestly, RSA encryption in general. It's going to be things in terms of financial data. Right now, cryptocurrency, I mean, it's growing for sure. But if you compare the market cap of cryptocurrency versus just the finance industry in general, I mean, you're talking a dramatic difference, right? Like last time I personally checked, the market cap of Bitcoin is around, I want to say it's around 100 billion, I think, if I remember correctly. I don't know what it is now, but obviously finance is at 16 trillion internationally. So, if I at least had to, and that was my intention with quantum computer, I would definitely go for general finance first before I even touch it.
So Goldman Sachs before Bitcoin. That's pretty much, yeah.
Pretty much.
Why do they rob banks? Because that's where the money's at. It's just not in crypto right now. Let's leave that for a minute. It was such a hot button issue. I really want to focus in on, explaining in lay terms, what is Conduit? Who's your customer, and what does it actually do? And are you the first in the space doing what you're doing?
So there have been people that have tried to do what we're doing, and they succeeded to varying degrees over the last 40, 50 years. So the first major attempt at this was Study at Home, and some people might be familiar with. That was in the 70s. And so it was the idea of pretty much you could donate or volunteer, what they call volunteer computing, donating your computing power to this network through the internet. that would then be harnessed for a specific application. In the case of studying at home, that would be searching for extraterrestrial life. Pretty much scanning images of different stars, different cosmos, different galaxies, looking for different signs. Fast forward, once you get to about the 90s, you get something called BOINC, B-O-I-N-C. This is at UC Berkeley. And it currently holds the record for the largest distributed network in the world at about 32 petaflops. And so with that, it was more of a generalized study at home, where it wasn't just for extraterrestrial life, but also for genomics and what have you, but strictly in a research perspective. What's unique about what we're doing is that it's specifically for business application. It can be done for R&D, but it's targeted at a business application. So in other words, study at home, BOINC is for, say, the researcher that's trying to crack genomics, or specific genomic code. For us, it'd rather be for, say, a large-scale pharma company, right, that's trying to improve upon their drug design, or, right, say it could be a government agency, say like the CDC, who's trying to predict the spread of a contagion.
Yeah, Ebola.
Exactly. And so we've geared it towards that, and then also is that we've made under the hood, we've made the technology different. That's why it's called collective computing, in the sense that it's able to pretty much handle a lot more powerful, a lot wider spread of computers. So just recently in the past few months, we partnered with MIT. They have about 100 petaflops of computation. We also work with the University of Nevada, Las Vegas as well, with their supercomputer. And these are, again, supercomputers are in the top 100, 500 supercomputers in the world. And so the point is that our technology is unique in pretty much two different ways. On the application level, it's for a business. And two is under the hood, is that it can handle a lot more nodes, a lot more computing power, a lot of different types of computers as well. Not just not just like a normal computer, not just a laptop, but also phones, GPU miners, cloud systems, anything. So it's a lot more versatile and powerful in that way.
So what stage are you right now? Are you looking for customers? Are you MVP? Where you are in terms of Conduit?
Right. So I've been working on this for a little while now. We officially incorporated in 2016. I actually started when I was a sophomore at MIT.
Okay.
And so since then, we've gone through a few different cycles. We've had, when we worked with 2,000 customers at a time with a partnership with WorkBar. And now that's a shared workspace that's got about 7 different locations across the United States. And long story short, pretty much we were working with these different audiences, and we would always kind of go back to the drawing board because we wanted to make it more of a targeted solution. Meaning that when we were working with 2,000 clients, each client had a different use case. So you almost had to make 2,000 different products to cater to that audience. We said, well, okay, hold on. So let's take a step back. Let's pretty much make one product that we can, really solve one particular problem really well. For us, instead of being like a generalized cloud solution, it's really I call it a big data engine. So what's the common between, CDC to, say, Novartis to, say, NASA is that it's a lot of data, and you're trying to make educated decisions based on that data, which requires in-depth analysis. Another example, too, of what an application that we'll be developing later on is around climate prediction. Right? So recently there was a hurricane that hit the Bahamas, it was Category 5. But if you looked at the forecast, the forecast changed every day. So it's going this way, and it's going that way. We didn't even know where to hit. So my uncle, who's actually part of the Miami-Dade Department of Transportation, 2 days before the storm, he has to organize everybody. He has to take people off of, their current posts and get, ask for emergency relief aid funds, what have you, all for it to not hit. Meanwhile, it hit Bahamas harder than we expected. And so it's a lot of wasted resources on both sides, actually. Ironically, both the people who were hit and not hit. And so overall, the product that we're creating, when we create with Conduit, is pretty much a big data engine. We've got a lot of data. We've got to figure out, how to use this data to make informed decisions. And that actually goes across industries, across product industries, and more it goes into the information industry fundamentally.
So would you have been able to, if someone invited you to the table, would you have been able to say, hey, you can use Conduit's computers right now. We know the hurricane is coming. This is the information that we get. Could you take a client right now?
Absolutely. We could have assistance to that actually earlier. And so right now we're actually in talks with MIT around some of their stuff around climate prediction seeing if we can, help augment some of their work as well for future, natural disasters. And then keep in mind that speaks to a larger theme here in the world, not just in technology, of pretty much the erratic behavior, the increasingly erratic behavior of the environment due to global warming. So you're going to see more and more of this type of stuff over the next, every day, really, but especially the next 50 years.
And what I know you sent it to me, but what is your website for those that are viewing? What's the URL for your website, and how's the best way people can contact you?
The URL for the website is conduit, CONVUIT, conduit computing.com. Let me see if I have my shirt on right here.
Wait. I think I got it. People's joining in the way, so I can't really see.
Oh, is it? Okay, hold on.
Yeah, I wanted to open up for questions. Those of you, I know there's a group of people who are watching, right. But I see Tessa said hi, but send some questions. Again, just to kind of summarize that Ryan's venture is called Conduit. The website is conduitcomputing.com. Essentially, he's decentralized quantum computing level power. So, for those of you who are familiar with storage, it's not space, it's power. And then really majoring into corporate clients and actual, to solve real big data solutions, using this power to kind of resolve problems. I don't see any questions right now, but what's on your wish list, Ryan? What's next for Conduit that you wish to happen right away?
Say that last part one more time.
I said, what's on your wish list in terms of what you want for Conduit right away? Like, what's the next steps?
So that's a great question. So in terms of big steps, I mean, honestly, for us, so we're still a startup, so for us, next year is when we're going to start really scaling up the operation of venture. So we're starting with fundraising. We've already got interest from a few major VC firms. So it'll be pretty much around, doing that when it's right, when we feel it's right to scale up business. We purposefully actually kind of held off on bringing in large scale capital until we felt like it was right, and we knew actually how much, funding we would actually truly need. That's another dangerous problem too. We've been taking too much money as well. So, in terms of our wish list moving forward, is we definitely want to, fundraise next year. And I think too is I really want to pretty much get a headliner in terms of the impact that that we're creating. Right now, this past few years has been sort of putting the Lego pieces together. Getting the software going, getting the computing alliances going. Next year is really when I'm excited to see, say it was a hurricane, God forbid, but is that we'll be able to predict, where it's going, and so that can save hours of time on the news, as well as, people's preparation as well. So my wish list is really, if I had to sum it up, is to have be in the position as an organization where next time around, next hurricane season, we're able to work with people to prevent as much damage as possible.
Okay. So how's the best way for people to contact you?
Say that one more time.
What's the best way for people to contact you?
Email. You can email me, ryan.robinson@conduitcomputing.com. I check my email all the time, so that's like the best way to reach me.
Okay, repeat that again.
So email Ryan, RYAN, .Robinson, ROBINSON, @conduitcomputing.com.
Okay, because I think people are kind of shell-shocked. I think the reason why we stopped doing these interviews for a while, because I've been sidetracked working on some other things, but it was so important to have you on, one, to dispel, kind of the fear rush that occurred with the Google leak, but also to explain to people that, there's a contingency out of MIT that are doing some very high level, not just decentralized, but high level, computing startups that don't get the attention that they should be receiving. So it was great having you on. I definitely want you to keep in touch and let us know, updates when you get a chance. We're connected on LinkedIn because you can always shoot me an update, and we'll bring you back on.
And there's actually, thank you so much for having me. And there's actually a group called Blockchain. Where it's a series of different entrepreneurs from different backgrounds from the African diaspora, from Nigeria to Kenya to Miami, that are working on different types of stuff. So I'd love to
Is
connect
blockchain with MIT or something else?
No, it's I mean it's people from MIT, but it's our own group, our own affiliation.
Oh, definitely connect me with that term. Now you're the third person to use that term. I think there's
You heard another
yeah.
blockchain?
Well, no. Well, here's the thing. It resonates really well. So people
Yeah.
are coming up with it independently. So Isaiah Jackson, I don't know if you're familiar. He's written the book Bitcoin in Black America, and he's on a book tour right now. He and his partner have a startup named Blackchain, and their goal is to, regardless of the startup, bring startups and VCs together on a blockchain. Then there was a speech given by Mona Hamdi, who is a fellow at Harvard, and she's Egyptian, and she gave a speech at Black Blockchain Summit saying, look, we need to look at decentralized solutions for solving poverty and other issues in Africa. We need to create a blockchain. So it keeps resonating really well with people saying, we've got this merger of problem solving within the Black community, whether it's funding for startups or whether it's just poverty or unbanked solutions, that merger of blockchain and with a attention to global issues involving Black people resonates very well. So this is you're the third blockchain, and I definitely want to know more about your blockchain as well.
Nice. All right, great. Well, yeah, thank you so much for having me, everybody.
All right.
Have a great one.
Take care. All right, I'm going to reverse the camera a little bit. Hold on one second. Let's see. And Tessa, thank you for drafting the notes. Every time I do a live stream, there's something that's a little bit different from the previous live streams because Facebook is changing and updating their live stream functionality. So for some strange reason, it's more difficult for me to like and comment while the live stream is happening. And then when I shared it, I noticed they went immediately into watch party mode, which they had never done before. You usually could just share a thing to a group and then keep on moving. But in any case, hopefully you were able to hear, just to summarize, if you couldn't hear, that Ryan Robinson, his startup is called Conduit. He is the world's first quantum engineer. And he explained why he knows he's the world's first quantum engineer. And his startup is blockchain-based, decentralized quantum level computer processing power. So that pretty much sums up, some of the things that he was talking about with his venture and the direction they're heading and the use cases for that venture. And, we're definitely going to stay in touch with Ryan to learn more about what MIT and Berkeley and all the collabs are doing. All right. So we'll talk to everyone soon. Take care.